Okay, I'm going to show you how to create a cumulative binomial distribution table. Let's start with this example. So x varies as a binomial distribution with 5 trials, and the probability of having a successful trial is 0.05. I could have said that the index is 5 and that the parameter is 0.05. That would be another way of describing that distribution. So we've got 5 trials, and that means there are a range of different possible outcomes. We could be successful, well, none of the trials, 1, 2, 3, 4, or possibly all of the trials could be successful. And what we want to do is to work out, to begin with, the probability of each of these different options. To do that, I'm going to switch to PowerPoint, not PowerPoint, Excel, and talk you through the options. So there we go. There's the different possible outcomes. First of all, we need to think about the binomial formulas that we'll use. So, if you remember, the first bit of this formula is giving us the number of arrangements, and if we're going to have 5 unsuccessful attempts, there's only one way you can do that. So that should turn out to be 5. When you type in 5C0 on your calculator, you should get that to be 1. This term is telling us then the probability of having 5 failures. We've got to do 1 minus p, that's the probability of failing, and if there are 5 of them, then it's to the power 5. So if you work that on your calculator now, you start putting some of these numbers in, you'd find that you're going to work out 1 for 5C0, and then 1 minus p is 0.95 to the power 5. Type that out in your calculator and you should get that value, 0.7737, and so on. The next one then is, there we go, what happens to the probability of getting 1 successful result. So that's going to be 5C1, p to the power 1, 1 minus p to the power 4. Probability of 1 successful trial and 4 unsuccessful trials. And again, if we work out what the numbers are there, it should look like that. 5 for 5C1, 0.05 to the power 1 is the probability of that 1 successful trial, and then 0.95 to the power 4 is the probability of getting the 4 unsuccessful trials. And there are 5 arrangements of that. So again, using your calculator, you can check this out. You should get that. Okay, so I'm going to pull these away now and show you the rest of them. They're the different probability formulas. Here's what it looks like if you put the numbers in, and this is what you should get as a result on your calculator. Okay, so you'll notice that some of these numbers get very small, and the spreadsheet starts to use standard index notation to represent them. Now, to create a cumulative distribution, all we've got to do is to add an extra column and add these up. So for the first one, which is going to be the same, to get the next value, we've got to add up this value with this one. There we go. And there we go. If I show you the rest, you can see how it builds up. Now obviously, when we add up all the probabilities, it comes to 1. Now there is actually a table that you're given in the exam. Let me show you the table. Where's that gone? There we go. There's the binomial cumulative distribution table. And what we've been working out, these values just in this little section here, and you can see it's saying probability is 0.05, n equals 5, and it gives us values for each of the different events, x equals 0, 1, 2, 3 and 4. It hasn't given us the value for x equals 5 because it would be 1 all the way across the table. Let's see if we can replicate some of these numbers by thinking about what's happened. If we go back to our spreadsheet and I get rid of this middle stuff, which is just the working out, then the spreadsheet starts to look like this. So there's our probability for each event, and there's our cumulative probability. We could tell the spreadsheet to round these to four decimal places, which is what the table does. So let's do that. So I'm going to tell it to round to 4 decimal places. Okay. Now what you can see is that those very small numbers, when you round them to 4 decimal places, come out to be effectively 0 to 4dp. And that means when we look at the cumulative distribution, it's going to go 0.7738, 0.9774, 0.9988, and then 1 and 1. We know it's not really 1, we just know that it's been rounded to that. So if you think about those numbers and compare them with the table, they should be the same. Let's see if they are. Oh, sorry, it's gone again. Where is it? There. Okay. So comparing these numbers with this list here. Now I've been quite crafty, because I've set my spreadsheet up to allow me to change the parameter. And let's see if we can get those two things side by side. Okay. So if I change the parameter here from 0.05 to 0.1, then the new values for the cumulative distribution match the second set of numbers in this table. And in fact I can use my spreadsheet now to go through and work out all of these numbers for binomial distributions where n equals 5. The table then goes on to show you loads of different results. So it goes n equals 5, 6, 7, 8, 9, 10, and keeps going 12, 15, 20, 25, 30, and so on. 40 and 50. Okay, and then we're on to the next thing, which is Poisson distribution. So I think I'll leave it there for now.